Hi team, welcome back to another screencast. We're going to finish chapter 8 today and cover sections 8.3 and 8.4. In section 8.3, we're going to talk about how human activities have affected marine ecosystems. Marine ecosystems are being disrupted and degraded at an alarming rate. Along our coastlines, it's development that's the major threat. On the continental shelf and in the open sea, it's overfishing and a fishing technique called trawling that are the major threats. The diagram on the left shows how trawling works. A weighted net is dragged along the bottom of the ocean, catching and collecting anything in its way and destroying habitat at the same time. The satellite image on the right shows the aftermath of trawling on a shallow ocean bottom. This is a resort in the Bahamas, and it shows how coastlines are a popular vacation destination. As a result, development in these places have really disrupted ecosystems. This map shows what San Francisco looked like before development. You can see all the different ecosystems that once existed here, and you can also see how the shoreline itself has changed through human activity. We are affecting marine ecosystems in a number of other ways. First, we are polluting the marine environment through both non-point source pollution and point source pollution. The photograph on this slide shows how runoff can carry plastic, trash, and other debris into marine ecosystems. Secondly, we're destroying habitat in a number of other ways. One example is aquaculture, or specifically shrimp farming. Shrimp farming operations have led to the cutting down of mangrove forests along coastlines so that they can set up these operations. And lastly, marine ecosystems are having to deal with the introduction of invasive species from one body of water to another body of water. One example is the lionfish that is native to the Pacific but is decimating populations of fish in the Atlantic. In 2010, an oil rig called the Deepwater Horizon exploded and sank in the Gulf of Mexico, causing the biggest oil spill in US waters ever. This is a good example of point source pollution. In 2007, there was an oil spill in the San Francisco Bay. A boat named the Costco Busan hit one of the towers of the Bay Bridge, releasing oil into the water. This is an aerial photograph of farmed shrimp in Belize. While farmed shrimp can protect wild populations of shrimp, it has its own drawbacks. This infographic from the textbook summarizes the impact of humans on marine ecosystems. The largest estuary in the United States, where freshwater meets saltwater, is the Chesapeake Bay in Maryland and Virginia, and it's been polluted since 1960 when it experienced a large population increase. The effects of this are twofold. First off, phosphate and nitrate levels in the bay are too high. This was caused by fertilizer from agriculture and people's lawns. Secondly, turbidity or cloudiness has increased because of sediments that have come into the bay from runoff. This reduces the ability of plants to do photosynthesis, and as a result, vegetation has decreased. Oysters are an important food species and keystone species in the Chesapeake Bay, and because of the changes to water chemistry and turbidity, their numbers were greatly reduced. In 1983, a number of governmental agencies and citizens groups banded together to create the Chesapeake Bay program to address some of these issues. After 25 years and spending $6 billion, the program failed to meet its goals. This example shows that prevention might have been a better route to follow. This photograph shows Chesapeake Bay oysters. This map shows how rivers carried pollutants from areas in green to the Chesapeake Bay, creating areas with no oxygen called dead zones and other areas with low oxygen. In section 8.4, we're going to talk about freshwater ecosystems and why they're important. First, we can divide freshwater ecosystems depending on whether the water there is still or moving. In places where the water is still or standing, we use the word lentic. These are our lakes, ponds, and inland wetlands. In places where the water is moving or flowing, we use the word lotic. These are our streams and rivers. Let's start with still, standing, or lentic systems. Lakes will have 4 distinct zones based on depth and distance from the shore. First is the littoral zone. The littoral zone is near the shoreline. It's where most rooted plants will grow and where biodiversity is the highest. You'll find animals there like turtles, frogs, crayfish, and fish. Farther out from shore and above the lake bottom, you'll find the limnetic zone. This is an open area, it's sunlit, and where a lot of photosynthesis by algae occurs. You'll find larger fish out here as well. Next, the profundal zone is still. Next, you'll find the profundal zone away from the shoreline and under the limnetic zone. It's too dark here for photosynthesis, and as a result, oxygen levels are low. You will still find some fish here though. Finally, there's the benthic zone. This is the lake bottom, and you'll find decomposers and detritivores here. You'll find some fish here and other organisms that depend primarily on dead matter for nourishment. This diagram shows the 4 lake zones, the littoral, limnetic, profundal, and benthic zones, and some of the organisms that live in each one of them. This infographic from the textbook summarizes the ecosystem services and the economic services provided by Freshwater Systems. When you look at a lake, sometimes it's very clear, and sometimes it's very green and murky. Clear lakes are called oligotrophic lakes, and they tend to have low nutrient levels and low NPP. They're clear because there's not a lot of algae growing in them. Lake Tahoe is an example of an oligotrophic lake. Green and murky lakes are called eutrophic lakes, and they tend to have high nutrient levels and high NPP. They're green because of all the nutrients that are in them. Stowe Lake in Golden Gate Park is an example of a eutrophic lake. Human activity can create eutrophic lakes. When we add nutrients, usually through fertilizer, to a lake, it leads to a process called cultural eutrophication. The photograph on the left shows another oligotrophic lake. This is Crater Lake in Oregon. On the right side is a eutrophic lake in western New York State. One problem with cultural eutrophication is the creation of dead zones with no oxygen. This occurs when bacteria breaking down dead algae consume all the oxygen in the water, leaving none for other organisms. Let's switch gears and talk about moving, flowing, or lotic systems. Any water on land is called surface water, and as it moves, it's called runoff. The area of land that carries water into any river, stream, or other body of water is called a watershed. This is a map of the Mississippi River watershed. Any water that falls in the green area on this map will drain into the Mississippi River and eventually the Gulf of Mexico. Water in a river flows because of gravity. Water flows downward from mountains and higher elevations. Rivers can be divided into three different zones. The first is the source zone, where the river starts. Water here is shallow, cold, clear, and swiftly flowing. Water in the source zone also has high dissolved oxygen. As rivers move out of the mountains and the source zone, they move into the transition zone. Rivers here tend to be wider, deeper, and warmer. They tend to be cloudier or turbid and have lower dissolved oxygen. Finally, they make their way into the floodplain zone. Rivers here tend to be wide and deep. They tend to meander a lot or curve and bend. They're often found in broad, flat valleys that are fertile because of the nutrients brought by the flowing water. This diagram shows the three zones of a river: the source zone, transition zone, and floodplain zone. In the floodplain zone, you'll find the river delta and where the river empties into a larger body of water. River deltas at the end of a river are significant because they're often home to coastal wetlands. These coastal wetlands can absorb wave energy and prevent damage during storms and hurricanes. Dams and levees have been built in and around rivers for energy and to prevent flooding during storms. Unfortunately, it also prevents the deposition of new sediment into floodplains and river deltas. This has led to the subsidence or sinking of places like New Orleans. Most of New Orleans is actually below sea level. The effect of all this is that these places are more susceptible to severe flooding during storms and are also more susceptible to flooding due to sea level rise. This is a photograph of New Orleans after Hurricane Katrina. The hurricane was so strong it broke levees that the city built around the Mississippi River, causing widespread and long-lasting flooding. This is a satellite map of Louisiana. The areas in red are areas expected to be flooding if there were to be 1 meter of sea level rise. Inland wetlands are freshwater wetlands located away from the coast. They're covered with water either all or part of the year. They include things like marshes, swamps, prairie potholes, floodplains, and Arctic tundra. They're important to life because they provide habitat. They're important to us because they provide a natural way to absorb and process toxins and pollutants. This is an example of a freshwater marsh. This is a swamp in Louisiana. These are prairie potholes in the Midwest. And this is a floodplain before and after a heavy rain when the floodplain is flooded. And finally, this photograph shows inland wetlands created by Alaskan Arctic tundra. Inland wetlands provide a number of free ecosystem and economic services. As mentioned before, they filter and degrade toxic waste. They reduce flooding and erosion. They help to replenish streams and recharge groundwater aquifers. They harbor biodiversity. And finally, for us, they provide food, timber, and recreation areas. This diagram further emphasizes the benefits of inland wetlands.